Hello, good afternoon to all. So today is our last interaction class regarding engineering mathematics 2, and in this class we will mostly focus about some of the properties of the Laplace transformation. And so the motivation behind today's class is so the definition of the Laplace transform is quite complicated because it contains integration, right? So you need to compute if your function is like ft, then your integral transform then the Laplace transformation is integration 0 to infinity e की power minus st into ft dt. Now if your ft, the structure of ft is too complex like that, e की power t square into sine square 3t, then integration of that type of function becomes a formidable task because you need to apply integration by parts successively, and whenever there is you will try to successively apply the chain rule, there is a high chance that you made some mistake. So I hope that you all know that what I am trying to mean to say, that what is the complication of integration by parts, because when you have this type of complicated function, then the integration by parts, doing integration by parts is itself a huge task, I mean. So there are some methods by which you can actually mitigate this type of problems. So one of such is like that, if evaluate Laplace transformations of this type of functions, like say e की power 5t into t cube. So e की power 5t into t cube. So you know that what is the Laplace transformation of t cube. So what will be t cube? The Laplace transformation of t cube will be factorial 3 divided by s की power 4, right? So similarly, like e की power minus 2t by cos 4 into cos 4t. So cos 4t, you know the Laplace transformation. For cos 4t, the Laplace transformation is s by s square plus 16. So you know the Laplace transformation of cos 4t. Now knowing that Laplace transformation, can you determine the Laplace transformation of e की power minus 2t cos 4t? So that thing we want to, and obviously we will do. So evaluating transforms such as Laplace transformation of e की power 5t into t cube or e की power minus 2t into cos 4t is straightforward, provided that we know that Laplace transformation of t cube and cos 4t. In general, if we know the Laplace transform of a function ft, then it is possible to compute the Laplace transformation of an exponential multiple of f, that is in terms of e की power at into ft, with no additional effort other than translating or shifting the transformation to fs minus a. So this result is known as first translation theorem. So what does first translation theorem tells? That if your Laplace transformation ft is known to you as fs and e is any real number, then Laplace transformation of e की power at into ft is f of s minus a. Just if ft is like f of s, just put s minus a instead of s, you will get the desired result. So just read with me the first translation theorem. So what does first translation theorem tells? That Laplace transformation of ft, where ft is a function, Laplace transformation of ft is actually e की power at into ft, and this transformation is actually f of s minus s, where capital F is the Laplace transformation of the function ft itself. So you just look on the proof. The proof is very much straightforward, and I hope that you can understand just by looking at the statement. So just you substitute the variable s with s minus a and you will get the desired result. So I am giving you 1 quick minute, just go through this what I am trying to say and try to summarize the thing. The first translation theorem, it gives us that if your function is multiplied by some exponential form type of thing, then the Laplace transformation of that combined function will be f of s minus a. So next we will try to solve the two problems which I have discussed earlier, that Laplace transformation of e की power 5t into t cube. So e की power 5t is like exponential type of function that is multiplied with the function t cube itself. Now, so how to determine the Laplace transformation of e की power 5t into t cube? So you have the function e की power 5t into t cube. So the result directly follows from the above stated theorem. So just e की power 5t into t cube. So you know that Laplace transformation of t cube is factorial 3 by s to the power 4. So instead of s you put s minus 5, and if you put s minus 5 instead of s, you will get 6 by s minus 5 whole की power 4. So this is the desired result. Now that is how the first translation theorem acts on your acts on different functions. So you can understand that if you need to compute these things manually, then your life would have been miserable. For example, this e की power minus 2t into cos 4t, you have to take you have to like determine, you have to do integration by parts and all, then you have to put the limits, and you can make, there is a high chance that you will make a mistake. So it is better to always remember the theorems and the associated formulas. Like Laplace transformation of e की power minus 2t into cos 4t. So cos 4t is a trigonometric function, and we know the Laplace transformation of cos 4t is s by s square plus 16. Now what you need to do, instead of s you need to put s of s minus minus 2, that implies s minus minus 2, that implies s plus 2, and s plus 2 whole square plus 16. So s plus 2 by s plus 2 whole square 16, and so this becomes s square plus s plus 2 whole square plus 16. Okay, now to compute the inverse of f of s minus a, we must recognize what is actually fs, then we need to just multiply the exponential of at. So it is, you have to perform the things in a in a revised order. Okay, so this is the symbolic thing that what I am telling you, that Laplace inverse of s minus a, f of s minus a, you determine Laplace inverse of fs, then put just multiply with e to power at with the actual function, this transformation of fs, which is actually ft. Now so there is a very nice example here. So how that example is, so you see that is 2s plus 5 divided by s minus 3. So what you will do, you will just write 2s plus 5 by s minus 3 whole square. This is equals to a by s minus 3 plus b by s minus 3 whole square. Now you can, putting the terms, you just multiply with s minus 3 whole square. If you multiply with this s minus 3 whole square, you will get a by s minus 3 plus b by s minus 3 whole square. By putting the two terms on the right hand side over a common denominator, you can obtain that 2s plus 5 is equal to a into s minus 3 plus b, and this identity yields a equal to 2 and b equal to 11. Therefore you can write down this 2s plus 5 by s minus 3 whole square equal to 2 by s minus 3 plus 11 by s minus 3 whole square. And similarly Laplace inverse of this, so this is 2 by s minus 3, so that is, you can think of like 2 by s and 1 by s, the Laplace transformation will be 1, so you need to multiply with e to power 3t. So from the first part you get 2 into e to power 3t, and from the second part you get e to power 3t into t, because the inverse transformation of s minus 3 whole square, the inverse transformation of whole square is actually and has no real linear factor in this situation. So this is 2 e to power 3t plus 11 e to power 3t into t. So this is your actual answer. Now next problem is like that, you need to determine the Laplace inverse transformation for the function s by 2 plus 5 by 3 by s square plus 4s plus 6, and s by 2 plus 5 by 3 s square plus 4s plus 6. Now you can check that the quadratic polynomial that is inside that is below the that is in the place of the denominator, that cannot be expressed in terms of square, that cannot be expressed in terms of multiple of linear factors. So what we will do, we will just write down it in a complete square type of form. So this is like s square plus 2 into 2s plus 6, so s square plus 4s plus 6, so that can be written as s plus 2 whole square. So if you put s plus 2 whole square, then it will becomes s plus 2 whole square plus 2, because you can write 6 as 4 plus 2. So s square plus 4s plus 4 plus 2, where s square plus 4s plus 6, s square plus 4s plus 6, so that s square plus 4s will be s plus 2 whole square plus 6. Now what you will do, you will just simply put into a square form and you get s by 2 plus 5 by 3, and the below you get s plus 2 whole square plus 2. So from the first part, so you always remember that this is like, so you need to think in the reverse manner. So here you have s plus 2 whole square, so here also you need to manipulate this s in, so that you can write in s plus 2, right? So here it will do, you will just put s plus 2 divided by 2 and you subtract by minus 1. So the above thing you can write is like this, half into s plus 2 by 3 by s plus 2 whole square plus 2. So that can be written as half into s plus 2 by s plus 2 whole square plus 2 by 3 into 1 by s plus 2 whole square plus 2. So this is actually, so s by s square plus 2 is actually the Laplace transformation of cos root 2 t. So what will be the Laplace transformation of this? This will be e to the power minus 2t cos root 2t, cos root 2 into t, and this will be root 2 by 3 into e to the power minus 2t sine square root 2 into t. So this is actually, so I am just giving 1 or 2 minutes, you can, so that you can just cope up with what I am trying to say, and you can just look through it, that half into e to the power minus 2t cos square root 2 into t, the square root 2 by 3 into e to the power minus 2t sine square root 2t. So this is actually the answer, and these things all we are doing by utilizing the simple first translation formula. Okay, so now we will solve an initial value problem. So this is a second order differential equation, like d2y dt square minus 6 dy dt plus 9y equal to t square into e to the power 3t, with the initial condition y of 0 equal to 2 and y prime 0 equal to 17. So before transforming the differential equation, note that it is its right hand side is similar to the function used in part A of example 1, t square e to the power 3t. So after using linearity, you need to using linearity, so Laplace transformation of this entire left hand side will be just addition of them. So d2y dt square, the Laplace transformation will be s square ys minus s y0 minus y prime 0 into minus 6 into sys minus y0 plus 9ys, and Laplace transformation of t square e power 3t will be 1 by s will be factorial 2 by s minus 3 whole cube. So you just combine the likewise terms, you get s square minus 6s plus 9 into ys equal to 2s plus 5 plus 2 by s minus 3 whole cube. So if you just like it can be written as s square minus 6s plus 9 into ys, so which can be written as s minus 3 whole square into ys. So this is written as 2s plus 5 divided by s minus 3 whole square plus 2 by s minus 3 5. The first term on the right hand side was already decomposed into individual parts in fraction 2 in part A of example 2. I will upload the note, no worry about it. So you can write in the first part in terms of like 2 by s minus 3 plus 11 by s minus 3 whole square. So this term will be 2 into e power 3t, the Laplace transformation, plus 11 into e power 11 into t into e power 3t. Then here you need to write 2 by factorial 4, that means 2 by 24, that will be 2 by 12, just to manipulate this numerator denominator term so that it can reduces to the Laplace transformation of t ki power 4. So that is how, but t ki power 4 but with a translation added, because here it is s minus 3 whole 5, so that will be t ki power 4 into e ki power 3t. So yt becomes 2 e ki power 3t plus 11t e ki power 3t plus 1 by 12 t ki power 4 e ki power 3t. So this is the answer. So I am just giving you 1 to 2 minutes, you just summarize the things. I am just like the entire question so that you can visualize better. So that is the problem which we have solved using this technique. Okay, I am just giving 1 to 2 minutes, you just go through it. So let's move without a delay, let's move to the next problem. So here we once again try to solve an initial value problem. And what is the problem? The problem tells that you need to solve d2y oh sorry, this problem, okay. So this problem is just like constituting of whatever, like the second problem which I have just discussed, where we have determined the Laplace inverse Laplace transformation. So here Laplace inverse transformation of d2y dt square plus 4 into Laplace inverse transformation of dy dt, and then 6 into y. So when you take the Laplace transformations, you will get from the first side you get s square into ys minus sy0 minus y prime 0 plus 4 into sys minus y0 plus 6ys. Laplace transformation of 1 is 1 by s, and Laplace transformation of e power minus t is 1 by s plus 1. So the left hand side reduces to s square plus 4s plus 6 into ys. So 2s plus 1 by s into s plus 1. So once again you divide by s square plus 4s plus 6, you divide it into partial fractions, and this s square plus 4s plus 6, this can be written as s by 2 plus 5 by 3. You can compute it, and you have already manipulated and determined this. So from here we will get, while computing inverse Laplace transformations, we will get only nothing, because this is just inverse transformation of 1 by only 1. So from here you will get 1 by 6, from here you will get 1 by 3 into e power t, and from here you will get the inverse Laplace transformation as minus half e power minus 2t into cos square root of t minus 2 square root of by 3 into e power minus 2t into sin square root 2t, because we have already determined the Laplace inverse transformation of this function. Where it is? Yeah. So here it is. Okay. So here we discussed about translation on the s-axis. Similarly, we can have translation on the t-axis, and for this purpose we will encounter the unit step function. So unit step function, the unit step function u of t minus a is defined to be u of t minus a is 0 and 1. That means if your t is less than or equal to a, then the unit step function is 0. Otherwise if t greater than or equal to a, then the unit step function is 1. So we will try to determine the inverse the Laplace transformation of t minus a. So this is So this is like a piecewise defined function, 20 to 20t if 0 less than or equal to t less than 5, and 0 if t greater than or equal to 5, and this is in terms of step function. Okay, so second translation theorem, that if fs is equal to Laplace transformation of ft and a greater than 0, then Laplace transformation of ft minus a into ut minus a is e की power minus as into fs. So once again, just go through it. I guess that Laplace transformation of f of t minus a into ut minus a is e की power minus as into fs. Okay, so also Laplace transformation of ut minus a is e की power minus as into a divided by s. So Laplace transformation of 1, Laplace transformation of 1 is 1 by s, Laplace transformation ut minus 2 e की power minus 2s by s, and it is e की power minus 3s by s. So here it is 1 by s minus 4 into e की power minus 2s. So the inverse Laplace transformation will be value will be u of t minus 2 into u of t minus 2 into e की power 4t. Sorry, 4 into t minus 2. Similarly, this s by s square plus 9 e की power minus pi s by 2, the inverse transformation will be the inverse Laplace transform will be cos 3t minus pi by cos 3t minus pi by 2 cos 3 into t minus pi by 2 into ut minus pi by 2. So this can be just cosine this, and you can write it as minus sine 3t. Just I am giving 2 to 3 minutes. Just try to encapsulate what I am trying to say. Okay, is anybody joined? Okay, nobody is here. Just giving 2 to 3 minutes. Just encapsulate the things. Okay, so now we will see cos t into ut minus pi. So your gt is cos t and your a is equal to pi. So g of t plus pi equal to cos t plus pi equal to minus cos t. So you can write it in terms of minus cos t into minus, here you can take minus like gt plus pi, you can write it like cos t plus pi. And what is cos t plus pi is minus cos t, you write here as minus, and cos t plus pi, and you can just adjust it to cos t plus pi minus pi. Cos t plus pi is minus t minus cos t. So that becomes Laplace inverse Laplace transform. Laplace of cos t will be minus s by s square plus 1 into e power minus pi s. Similarly, there is another Laplace initial value problem. Okay, so your problem is dy dt plus y equal to ft, y of 0 equal to 5, where this function ft is 0 if 0 less than or equal to t less than pi, and this is equal to 3 cos t if t greater than or equal to pi. So the function f, this can be written as ft equal to 3 into cos t into ut minus pi. So by linearity, the result of example 7, the just example which I have discussed just before, and usual partial fractions, you can have Laplace transformation of this as plus Laplace transformation of that is equal to Laplace 3 into Laplace transformation of cos t into ut minus pi. So this becomes Laplace transformation of y, and this becomes 5 by s plus 1 minus 3 by 2 minus 1 by s plus 1 e की power minus pi s plus 1 by s square plus 1 e की power minus pi s, and plus s by s square plus 1 e की power minus pi s. And you know that e की power minus pi s, what does it do? So here this thing you already have determined the Laplace inverse transformation. So from first you will get only 5 into e की power minus t. From the second you will get this thing e की power minus t minus pi u into t minus pi into Laplace inverse this e की power sin t minus pi into ut minus pi. And here also this will be sin cos t minus pi into ut minus pi. Thus the inverse of 17 will be written as 5 e की power minus t plus 3 by 2 e की power plus 5 by 2 e की power minus t minus pi ut minus pi minus 3 by 2 sin t minus pi ut minus pi minus 3 by 2 cos t minus pi. And then you just put it in terms of all the results. So I am just giving you 1-2 minutes to just summarize this result. And so that will be for today's class. So just I am giving you 1 to 2 minutes just to go through the this slide, just to go through the slide. So okay, so thank you very much for joining, and also my online listeners, thank you for all. So that's all for today. You just go through it, and if you have any doubt you can mail me up. So thank you.